औज़ु बिल्लाहि मिनश शैतानिर रजीम बिस्मिल्लाहिर रहमानिर रहीम अस्सलामु अलैकुम रहमतुल्लाहि व बरकातुहू. Today we are going to start polynomials. Okay? Polynomials. Definition. A polynomial is an algebraic expression of the form a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus a3 x power n minus 3 plus dot dot. Similarly, we have to increase base value a1, a3, a4 and decreasing nn or n minus 1 from power x power n minus 1, n minus 4 and 5 like that. The last term is previous last term x n minus 1 x power 1, that means there is no need to write 1, so just write x plus the last one is a to a n, here x power 0, that means x power start from n to constant term, that means constant term has x power as 0. So again a0 x power n plus a1 x power n minus 1, a2 x power n minus 2, a3 x power n minus 3 plus dot 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 a n minus 1x plus a n, where n is a non-negative integer, non-negative number. N is non-negative number. It is non-negative integers means whole number or integer, positive value you have to take 0 or 1, 2, 3. So that is non-integer, non-negative integer. X is variable of this polynomial. X is variable of the polynomial, and a0, a1, a2 dot dot an are constant called the coefficient of a0 is coefficient of x power n, a1 is a coefficient of x power n minus 1 variable, a2 is a coefficient of x power n minus 2 dot 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 x, a n minus 1 is a coefficient of x1 and 0 x power 0 an is the last term is a coefficient of x power 0, that is constant term. X power 0 is 1 into some number is constant, so this is a constant term and it is a coefficient of x power 0 respectively is the polynomial. These are the coefficients of these variables, where this term is very important one, a0 xn, this type of term, all terms are in this form only. Terms, all terms are like that, axn. If you put 0, you will get n minus 0. If you put 1, a1 x minus n minus 1. Like that we have to get all terms. These are the individual terms. 2 ax n minus 3. These are all individual terms of the polynomial, where a1, a2, a3, these are the coefficient, these x as variables, these are power. Power is in terms of n value, that is non-negative. Now these are the, now n is called degree of polynomial Now n is what? N is a highest power of the term in all terms of the degree, all terms of the polynomial. So this is the highest, n minus 1, 1 less than this, 2 less than. So like that power is going to decrease. So highest power term is there. This is a highest power term. So n is there. N is called degree of the polynomial. Now take example, and polynomial is expressed in terms of, expressed as each and every polynomial is expressed as p of x variable, x is there, or f of x, or g of x, or p of y. So it is a polynomial y as variable. It is a polynomial p, x as variable. F is a polynomial with x as variable. G is a polynomial with x. Hx, h is a polynomial, and anything we can write g of y, g of z. So this the term, the letter which is in a within bracket is there, within parenthesis, these are called variables, and these denoted that polynomial. These denote letter p, f, g, p, h. This represents polynomials. Now this is take an example. 3x square plus 5x minus 6 is a polynomial. Here 3 and 2 highest power, here 1 power is there. This is no power, x power 0, that is. So 2 is n equal to what? 2. So this is degree of polynomial. Degree of polynomial is 2. This is degree of polynomial, n equal to 2. Highest power of x, variable x. This is highest power of variable. Okay, this is highest power of variable. And a n is what here? 3. This is constant, and this is nothing but coefficient also. Coefficient of term, or coefficient of x square. We can say that coefficient of x square. Here we are taking this as first term, that is coefficient of x square. Again a0, that is first one. a1, 5 is there. a1 is 5. 5 is what? Coefficient of x. Coefficient of x. This is 5. And 6, that is a2 here. Highest power is 2, so a2, that is 6. Or minus 6 we can take. This negative sign is there. So this is called constant term. So like that we can differentiate power, coefficients and variable. Here variable is what? Variable is x. And this polynomial we can represent it as suppose px equal to what? Px is 3x square plus 5x minus 6. Like that we can represent any polynomial. Suppose I am writing here p of x, another polynomial, x cube minus 8x square minus of 5x plus of 20. So here degree is what? Degree is nothing but highest power, that is it has 0 power, 1 power, 2 power, 3 power. So degree is 3. Variable is what? X. Now coefficient, it has 1, 2, 3 coefficient, one constant term. Constant term in this one is 20. And coefficient of x cube is that what? 1. Coefficient of x square is what? Minus 8. Coefficient of x is here minus 5. Like that we can differentiate a polynomial and degree, variable, constant, coefficients of each and every term. A cubic polynomial have maximum 4 terms, minimum 1, maximum this. So we can take the examples of this cubic polynomial. Highest power should be this. This is 1. We can write this plus 2x, 2 terms. Again we can write x cube plus x square plus constant term, or we can write x cube plus 2x power x plus 5x plus 6x square. So how many terms are there? Maximum 4 terms in a cubic polynomial, and 2 terms also possible, 1 term also possible, 3 term also possible. So a cubic polynomial have a cubic polynomial, cube is a degree, a cubic polynomial, a cubic polynomial have 1 term, maybe 2 term, 3 term and 4 term, all are possible, but it must contain this term, cubic term, okay, it must contain what? The highest term, this term. If this term is there, so like that we can write for any other also, any other polynomial. Now degree of polynomials. Five examples are there. See here, 2x square minus 5x square plus 6. Here degree is 3. That means highest power of x is 3. So this is our degree 3. Here 1, 2, 3, 4, 5 terms are there. Which term contains highest power? 0 power, 1 power, 2, 3 and 5. So 5 is the degree. So these are these terms, these numbers highest. Here first term 4 degree, 4 as a power, second term has 8, third term is 1, 0. So 8 is the highest one, so this is degree. In this one also first 5, 4, 9, 15. So highest x power is 15, so this is the degree, 15 degree of this polynomial. Again one polynomial is there, first term 2, second term 1, third term constant without this is x degree, 0 degree, but here a term has 100. So the degree of this polynomial is 100. So like this we can differentiate the degrees. Now constant polynomials or constant values. Second point we are taking as constant polynomial is what? A polynomial in which no variable is there, only constant. Example take minus 5. Okay. Second example 20. Another third example. These are the constant terms. Minus 5 by 3. Okay. Any real number. Fourth one 7 by minus 8. Fifth one 1. Sixth one any number 100. Seventh one minus 100, minus 200, any value, or we can write the variables, not variable, constant as R, P, Q, A, B, C, D also. So these are the constant terms where variable is not there. So this is called constant polynomial, whose degree is degree of, remember that, degree of constant polynomial is always equal to 0. Degree of constant polynomial is always 0. Linear polynomial. A polynomial of the form ax plus b. A is not equal to 0. If you take a is 0, so you will get only b, constant term. So it changed the meaning. If a value is 0, so linear will change to constant term. That's why we have to take this condition. A should not equal to 0. Is called a linear polynomial. Ax plus b form is called a linear polynomial. Why? Because it is a line. This polynomial gives as a line. So this is called linear polynomial, where x is variable, a is coefficient of x and b is a constant term. Its degree is, for linear polynomial, always degree is 1, and it has only one 0. It has only one 0. General form is ax plus b. Example we are taking here. First example is 3x plus 2. Take another example, 8x minus 3. Okay, or like that we can write 9x plus 3 by 2, or 2 by 3 by 2x, 3 by 2x plus 7 by 5. Any number you can take, but variable is only x term and constant term should be there in a linear polynomial. Now quadratic polynomial. A polynomial of the form ax square plus bx plus c. Again a is not equal to 0. If you take a as 0, so this term is nullified. You will get only these two terms. So quadratic change to linear. That's why this condition is there. Is called a quadratic polynomial. Its degree is what? Its degree is 2. For a quadratic polynomial, always degree is 2. It has maximum 2 zeros. If a quadratic polynomial, the 2 degree, 2 zeros. 2 zeros maximum means it has 2 zeros. Sometimes we get 2 zeros as equal numbers. Equal or duplicate zeros. Duplicate zero means a quadratic polynomial have 2 5s, 2 2s, 2 3s. So only we will get 5. But it has another degree, another zero is also same 5. That's time we will get 1 0 also. Cubic polynomial. A polynomial of form ax cube plus bx square plus cx plus d equal to 0 is a polynomial of form this is called a cubic polynomial. Its degree is 3. Again it has maximum 3 zeros. Here 3 zeros are different, 3 different numbers, maybe 2, any of 2 are different number, all 3 also different number, all things are possible. Suppose a value 2 is 0, another 3 is 0, another 6, all 3 are different one, we get 3 zeros suppose. If all any 2, 3, 2, 2, 6 is there, then these two values are considered as one. This, it has 2 zeros means two values are same. Sometimes we can get that 6, 6. Sometimes we can get this and this also same. And sometimes all 3 are equal means 4, 4, 4 is there. All 3 values, all 3 zeros are same means we will get only 1 0. All are duplicate. So 3 for 3 degree 3 is there. The 3 it has 3 zeros. Okay, like this we can differentiate the polynomials. Now, biquadratic polynomial. A polynomial of form ax power 4. 4 is there. If highest power is 4, we call it as biquadratic polynomial. ax4 plus bx cube plus cx square plus dx plus e. A is not equal to 0. Again, if you take coefficient of x4 is 0, so you will get these terms. Highest power should be 3, so this change to cubic polynomial. That's why the highest coefficient not equal to 0 is called a biquadratic polynomial. It has 4 zeros, its degree is 4. Value of a polynomial. The value of polynomial px at k, where k belongs to real number. Px is a polynomial. We are going to substitute k in place of x. So we will get that pk. Pk is called a value of the polynomial. Here substituting k, we get in place of k as x. Substituting k as x, we will get pk. Px value is pk. We represent that value as pk. 0 of a polynomial. A real number k is called 0 of a polynomial px. If pk should be 0, pk is have any value. If pk particularly is 0, then we can say k is a 0 of the polynomial. The value who makes the whole function as 0, that x value is called k, 0 of the polynomial. It get any value, pk get any value. If it is equal to 0, then we call that k which makes 0 the whole polynomial, then that k is called 0 of the polynomial. Or otherwise all other numbers are there, that then we can say k as a 0 of the polynomial. Okay, So remember these two things. Value is different. If value is 0, then k is called 0 of the polynomial. Graph of a polynomials. Now we can draw the graphs. If substitute the points of the linear or quadratic or cubic or biquadratic, we will get some type of graphs. So graph of a linear polynomial is always a straight line. Whether this way or this way, any straight line, slightly or perpendicularly or horizontally, horizontal or vertical or slant, anyway, but we will get a linear as a straight line. We will get a straight line for linear polynomial. For quadratic polynomial, always we will get a parabola. Parabola shapes are like this. Okay, we will get U-shaped figure, that is called parabola. Graph of a cubic polynomials are curves type. So it goes down and ups infinitely, but it will not turn, not take a turn. So this type of figures, this type of graphs, curved graphs are called cubic polynomial. Like that we will get different types of graphs. Here we are discussing only linear, quadratic and cubic in your syllabus. Now questions are there. Find 0 of linear polynomial. So this is there. Now we can solve this. Okay. Find 0 of linear polynomial. Now just this is a linear polynomial. We have to compare this. Direct method is there. One method, substituting method is there. So first we are doing with direct method. Given is, the given linear polynomial is what? Linear polynomial is 3x plus 5. Now compare this value with 0. 3x plus 5 equal to 0. Now move that number, this to this side, minus 5. Plus 5 change to minus 5. X equal to minus 5 by 3. So this is 0 of the polynomial. Direct method is there. 0 of this polynomial. Therefore 0 of P of x is minus 5 by 3. Where this answer is there, that is your bit. Second question, we will solve 2 or 3 with this method, then substituting method we will follow. So suppose we are taking 6x minus 12 is a polynomial. So what way, this is a linear polynomial. Given linear polynomial is 6 minus this. Compare with 0, comparing with 0, equate with 0. So what you will get, 6x equal to plus 12, x equal to 12 by 6, this equal to 2. So this value of x 2 here. So the 0 is called 0 of px. Px means this 0 of px, that is 6x minus 12 is what? 2. So this is the 2. Now another method is substituting. Substitute value of x, which value of k gives as 0, then we can call it as a 0 of this. So substituting method or trial and error method we are going to follow here. Here see this 3x plus 5 is there. Now at x we are supposing x equal to 1. So what we are getting here, px, so let it as px equal to p1 equal to 3 into 1 plus 5. This is 3 plus 5, 8. So not equal to, this is not equal to 0. So this is not a 0 of the polynomial. Now we are substituting minus 1, px, again 3x plus 5. Now substitute p of 1, p of minus 1. Okay, p of minus 1 equal to 3 minus 1 plus 5. Again minus 3 plus 5. That is 2. 2 again not equal to 0. What we have to do? So think that if you substitute here minus 5, what happened? minus 5 by 3, 3 get cancelled. So this we are taking x as minus 5 by 3. So P of x is what? Again 3x plus 5 is there. So we will get P minus 5 by 3. So 3 minus 5 by 3 plus 5. 3 ones are 3 get cancelled. So what we left? Minus 5 plus 5. Plus 5 minus 5, 0. So this is very important. We get 0. 0, when we get 0, at this value, at x equal to minus 5 by 3. This value at x equal to minus 5 by 3, we are getting the whole function value is 0. Therefore, p minus 5 by 3 equal to 0. This 0 we are getting at this value is called 0 of polynomial. 0 of polynomial is minus 5 by 3. This is a method. By substituting, we can get a point when the function is 0. The whole polynomial value is 0. That making value, that x value is called a 0 of the polynomial. So linear equation have only one 0. These are the examples. Now taking more 3-4 examples for linear only. 2 by 3x plus 8 by 5. If it is a linear polynomial, yes, one term is a linear polynomial. Now compare with this. We have to just compare with this. Move this number to that side. 2 by 3 x equal to minus 8 by 5. X equal to, take the move this number into, goes to that side is divided this by this, or reciprocal of this you have to take 3 by 2. When you move this number, this, now this is nothing but 2 ones are 2 fours are, so minus 4 into 3 divided by 5 into 1, so it's minus 12 by 5. The 0 of the polynomial is 12 by 5. Verification, or we are checking that the whole function is going to change 0 or not. So this is our function 2 by 3x plus 8 by 5. Okay, now substitute x as here at a minus 12 by 5. What value of this? Minus 12 by 5 we are substituting. So 2 by 3 into minus, into is there, minus 12 by 5 plus 8 by 5. This is the value of this one. Now checking, it goes 1, 3 ones are, 3 fours are. Okay, this is how much? 2 fours are 8, minus is there, minus 8 by 5 plus 8 by 5. So this is same number are there, positive and negative. Positive minus negative 0. We are getting this value minus at minus 12 by 5. The polynomial value is changed to 0. Therefore, the 0 of this polynomial, 0 of px is minus 12 by 5. So this is the 0 of the polynomial. Now another example, half into x minus 7. P of x is what? 1 by 2x minus 7. Now you have to find value, x value at which the function is 0, or 0 of the polynomial you have to find. We can compare these. Therefore 1 by 2x minus 7 equal to 0. Now move this number, 1 by 2x equal to 7. If you move negative number to other side of equal, it will be positive. Now this is nothing but this denominator goes to multiply with that into 2. 1 into x is x equal to 14. If x equal to 14, you will get the whole function is 0. At x equal to 14, we are going to check here. P of x equal to 1 by 2x minus 7. Now substitute 14, x is 14. 1 by 2 into 14 minus 7. So you will get 2 ones are 2 sevens are 1 sevens are 7 minus 7. 7 minus 7 is 0. So this value makes the whole function as 0. So 0 of p of x is 14. Okay, this number is called 0 of the polynomial.